The concentrations of two chemicals in a reaction are known to decay according to the pair of differential equations given here, subject to these initial conditions. Z1 is x plus y and Z2 is x minus y, and we want to show dz1 dt is negative z1, and dz2 dt is equal to negative 3z2. So z1 is equal to x plus y. Therefore dz1 dt would be equal to dx dt plus dy dt. dx dt is y minus 2x. dy dt is x minus 2y. So that gives us minus x minus y, which is minus x plus y, which is minus z1. Now, z2 is x minus y, doing the same sort of thing. dz2 dt is dx dt, take away dy dt, which is y minus 2x, take away x, take 2y. So that gives us y minus 2x minus x plus 2y, which is minus 3x plus 3y, which is minus 3x take y, which is minus 3z2. We now want to solve these differential equations for z1 and z2 and hence deduce expressions for x and y. So this is a separable differential equation. We can say 1 over z1 dz1 is equal to dt, negative dt, and integrate, and then we get ln z1 is equal to minus t plus a constant. We could take exponentials of both sides, so z1 would be e to the c minus t. And then we know that e to the c could just be written as another constant, so z1 is a e to the negative t. So we'll just leave that one there for a second and work on this one, and then we'd have that the integral of 1 over z2 dz2 would be the integral of negative 3 dt. So that's ln z2 is equal to negative 3t plus a constant. So z2 would be e to the c minus 3t, and then we can say that z2 is ae to the negative 3t. In fact, we better call that b because it needs to be a different constant to this one. Now, z1 is equal to x plus y, and z2 is equal to x take away y. That means that 2x would be equal to z1 plus z2. So x is z1 plus z2 over 2, and therefore x is ae to the negative t plus be to the negative 3t, all divided by 2. Now, if we'd actually subtracted here, we'd have got 2y is equal to z1 take away z2. So that would give us that y is z1 take z2 over 2. So y would be ae to the negative t take away be to the negative 3t over 2. Now, we're told that x of 0 is equal to 1 and y of 0 is equal to 4. So we have 1 would be a plus b over 2, which means that a plus b is equal to 2. And then we have 4 is a minus b over 2, which is a minus b is equal to 8. So adding these gives 2a equals 10, which means that a is equal to 5. And if a is 5, then b must be negative 3. So x is 5e to the negative t. Take away 3e to the negative 3t over 2. And y is 5e to the negative t plus 3e to the negative 3t over 2. R of t is equal to y of t divided by x of t. So that's 5e to the negative t plus 3e to the negative 3t over 2 times 2 over 5e to the negative t, take away 3e to the negative 3t, which gives us 5e to the negative t plus 3e to the negative 3t over 5e to the negative t, take away 3e to the negative 3t, and then if we multiply right through top and bottom by e to the t over e to the t, so we're multiplying the top by e to the t and the bottom by e to the t, that would give us 5 plus 3e to the negative 2t over 5 take 3e to the negative 2t as required. Prove that r of t decreases for all values of t. So it's a quotient. So we'll have u is 5 plus 3e to the negative 2t. And v is equal to 5 minus 3e to the negative 2t. So du dt is going to be negative 6e to the negative 2t, and dv dt is going to be 6e to the negative 2t. So dr dt would be this one times this one, so negative 6e to the negative 2t, to 5 take away 3e to the negative 2t. Take away this one times this one, so that's 6e to the negative 2t into 5 plus 3e to the negative 2t, all divided by 5 minus 3e to the negative 2t, all squared. So that's negative 6e to the negative 2t into 5 take away 3e to the negative 2t, take away 5, correction, add 5, plus 3e to the negative 2t. These will cancel. All over 5 take away 3e to the negative 2t squared, and that gives us negative 60e to the negative 2t over 5 minus 3e to the negative 2t squared, and that has to be less than 0 for all t, because we know the exponential function is never negative. What happens to r of t as t tends to infinity? So we know that e to the negative 2t will tend to 0 as t tends to infinity, so r will tend to 5 over 5 is equal to 1.